This is the dashboard I built for my truck. At the top you can see the time of day. You get a map showing the vehicle on the road, and it moves around as you drive. On the right side you have a little battery gauge showing we're at 82% charge right now, voltage of 82.94. The current measurement is what's flowing through the shunt. We have the throttle position from the motor controller, and then the actual temperatures from the thermistors and the batteries. If it was daylight, you would get some amount of solar power coming in. At the bottom we have two gauges for kilowatts of total battery power, and then speed in kilometers an hour. All of this is running off the computer under the dash, and it's reading the motor controller over USB. The power numbers are being measured off the BMS over CAN. Everything updates pretty quick. So if we were to kind of step on the pedal here, you would see some quick burst of power, and you can kind of see the gauge actually working there. Some of the other features is we have either kind of like a vehicle up option or a north up, and you can easily toggle between them. We have a full light mode and dark mode, and then you can change the screen brightness depending on time of day when you're out driving. If you do turn off the manual center, then you can use it just as a normal map and look around. So this is all running on Linux. You can kind of look here and see the full Ubuntu desktop, and I've basically just written the web app. So it's running in Firefox right now, and I typically run it as full screen, and the screen turns on and off with the ignition. So it's always running in the background.
In addition to the live dashboard that I built that runs actually on the vehicle, I've also built out a Grafana dashboard that shows the historicals of everything that's recorded on the vehicle. So at the top right here you get a map. You can see the battery voltage over time. This is when we were just kind of doing that drive around the block. You can see the voltage sag as I'm accelerating. Using the GPS, it's calculating the total distance that was driven over that time. You can see as I'm dragging the cursor on the map, you can see exactly where I would have been at that point. Battery power, you would see down here, was down to about 31 kilowatts output as we were accelerating quickly. And then the corresponding speed from the GPS as well. As we scroll down, you can see an efficiency graph. This is calculating the relative speed to power output to go that speed. You can also see altitude from the GPS, bearing. Further down, I also have all the throttle outputs from the motor controller, so you can see if it's over temperature or anything like that in the summer. And then as we go further, we can kind of see more of the data that's actually available from the BMS. So we've got cell voltage, so this is like the highest, the lowest cell, and the mean. And then we get a graph of the spread, so you can kind of see how much the highest cell is deviating from the lowest over time. So as I'm accelerating quickly, you can kind of see that's where that biggest spread of, in this case, 26 millivolts is kind of coming to be. But generally it's sitting around 2 or so. Also built out a heat map, so you can see exactly which cell is lower than the others. So we can actually zoom in on this as well, and you can see that cell number 7 and 8 are kind of the ones that are sagging the most under accelerations. So this has been a great way to kind of like look back historically and learn a bit about the performance of the vehicle, and it's helped me kind of troubleshoot some little issues here and there, because you can see exactly what's going on after the fact at a really high resolution. So I'm using Grafana for the front end, but I've built out an InfluxDB database as the back end, and this is what's actually storing that data as it's coming in. So we have some general statistics in here. Under GPS, this is all of the data that's coming in off of the GPS that's mounted on the roof. Speed is generally the one of most interest, but you can kind of see some of the other things that are available. As we come into some of the power ones, we get all the BMS faults, cell voltages, charge states. If you click on any one of these, you can see exactly the kind of charge curve as it's been charging right now. Thermistor values. So it's at about 12 and 14 degrees C. everything coming in from the solar panels. So we have current, energy, power, and voltage. And then I've also decoded some of the fields from the motor controller that I'm using, but not all of them. So we have battery voltage, motor current, and then some of the throttle positions. And then I have a whole bunch of unknown fields that I haven't figured out what they correlate to yet. And then finally, since this is all running on Linux, I'm doing some data collection on the actual Linux computer as well. This is a graphic I made that shows all of the systems running on the computer and kind of how they all work together. So at the core is an MQTT broker called Mosquito, and this is sending and receiving messages from all the different services I've written, and then is providing data to the dashboard as well as InfluxDB. So it's kind of the key piece here. That dashboard that I showed that's on the touchscreen in the truck is running on a local web server on the vehicle, and it sends and receives data over MQTT to the message broker. And then I also have a Telegraph service, which is pulling data from MQTT and logging into InfluxDB, which is running as well. In between the two, I have an instance of Node-RED for some little automations and things that are easier to kind of drag and drop in program rather than writing a whole service for. So it's able to subscribe and publish to the Mosquito broker, and then also subscribe and publish to InfluxDB. And then finally I have Grafana that's running as a dashboard and is my way of visualizing all the data in Influx. On the left you can see all the physical devices that I'm running and how they kind of interact with the computer. So at the top we have the energy monitor, which is monitoring the solar power production. This is connected over a USB RS485 converter and shows up in Linux as TTY Solar. I've written a service that collects data over the Modbus interface, I believe, and then publishes that over MQTT. Next up is a GPS. That's just a simple USB GPS mounted on the roof, and that is plugged in over USB and shows up as TTY GPS. And similarly, I've written a service in Rust that pulls in the data from the GPS and publishes it over MQTT. Now the BMS is connected over CAN, so that goes into a USB to CAN converter, and then that actually shows up on the network as CAN 0. And then I've also written a custom service here that is able to send and receive messages following the whole API documentation for that device, and then those messages are also published over MQTT. Next up is the Ultrax motor controller that I have. That's a USB connection directly into the computer, and this uses the USB HID libraries. So that's one I had to reverse engineer kind of how it works because it's only supposed to work on Windows, but I was able to kind of figure out what those different registers are in using USB HID, and I've pulled in the most relevant ones, which are now visible. Next up is the touchscreen, and this is kind of the opposite of all of them, and it's actually providing control over the touchscreen over USB. So the screen shows up over HDMI, and then I have a couple buttons in the web dashboard, as well as some events that are triggered from Node-RED that actually turn the screen on and off automatically and adjust the brightness. So overall, everything here on the left is a physical device that you could buy off the shelf. These are all services that I've written, and I will be posting a link to my GitHub where you can download these as well. And then these 5 modules are all off-the-shelf open source services that you can download and run as well. So next up is my GitHub page for this. So far I've just kind of taken all of those different services that I walked through and posted them all here under one project. So there's probably a little bit of tweaking that needs to happen to get them all to run on your own system, but there's no reason that you wouldn't be able to kind of use any one of these different building blocks for your own vehicle. So each one of the folders here corresponds with one of the blocks on the previous page. So we have the Ultrax, which is a motor controller. The dashboard is actual web app that I built. The display service is for controlling the touchscreen. Energy monitor is for monitoring solar power. We have the GPS, which is evident, and then the MCU is for the BMS. So as we scroll down, you can see the different services listed as I was talking about, and the links to the actual devices that I'm using and how they communicate, and then a screenshot of that graphic that we just went through. So as you can see, everything's written in Rust as services, with the exception of the touchscreen web app, which is all JavaScript and React.